This video is going to help you with transformations and identifying parts of a graph for radical functions. So first I want to point out, we notice we have radicals in each of these equations and they're both square roots. So if we just hop over to Desmos real quick, this is our parent function for the square root function. So we'll notice it starts at the origin and then it goes off forever to the right. So the end behaviors, it goes to the right. The x's are going to positive infinity and the y's are also going to positive infinity. So we can use this to help us with our transformations. If we look back at this slide, I'll kind of draw my parent function in green. I'll do dotted green lines. So that's our parent function. So if we use that, that's going to help us identify how to move the graph. So the parts of these equations are the exact same as we've been doing for all the other functions transformations we've observed this year. So starting with the number closest to the x, that is going to be our horizontal shift or a horizontal translation. And it's going to have the opposite sign of the direction that it goes. So since we have +2, we are going to move left 2. And then this -4 on the outside is still our vertical shift or our vertical translation. And the sign follows the direction you would think. So since it's a -4, it is going down 4 spaces. And then on this equation, we also have a 3 in the front. So that is showing us a vertical stretch or compression. In this case, since the number in front is 3, which is greater than 1, we get a vertical stretch by a factor of 3. So now when we go to graph this, the first thing I'm always going to look at is the vertex. So the vertex was at the origin, but it's shifted left 2 spaces and down 4. So this is going to be my new vertex. And then it's going to go off to the right, but I want to see what that vertical stretch is. So I might graph it first on Desmos to see. So we have 3 and +2 -4. So you can see this stretch, it's like if you were to hold the top and the bottom and pull, it stretches it, so it looks like it's going higher up to the right, whereas the original function is kind of a little more shallow. So you'll see this vertex is right where we thought it was, -2, -4, and it intersects the x and y axis right at about these points. So I'm just going to roughly sketch that it kind of goes like this. So a few things we might want to point out. We said what the vertex was. Notice those x and y intercepts. So on this one, they happen to be decimals. So this is our x-intercept because that's where it's touching the x-axis, and our y-intercept where it touches the y-axis. And then let's consider the domain and range. So the domain, considering what x values it can be, well, looking at the x-axis, the furthest left it goes is at this point, -2. So -2 is the smallest x value, and it's included because of that vertex point. It's a closed dot. As I go to the right on the x-axis, this arrow shows me it's going to go right forever to positive infinity. If we think about the range, what the possible y values are, we use the same thought process. So looking at the y-axis, the bottommost y point is right here at -4, and it's included, so I use that hard bracket because of the closed dot. As I go up forever and ever on my y-axis, this arrow on the end is showing us that it's going out and up forever. So positive infinity would be my greatest range value. All right, and we'll just look at one more over here. So on this second example, we see we have x minus 2 on the inside. So a horizontal shift, it's going to go 2 units to the right, because it's that opposite value. There's no numbers on the outside, so we don't have any vertical shift here. But then in the front, we have a -2. So we have a vertical stretch by a factor of 2. And then that negative in front is really important. So the negative in front means it has been reflected. And as we've seen before, it's been reflected on the x-axis. So to plot this, I can identify my vertex. So it's gone 2 units to the right and it did not have a vertical change. The negative means it's going to go upside down now, but the stretch is going to make it bigger. So it might look something like that. And as always, you can check your work on Desmos. And there we go. So in this case, we have no x-intercepts. Well, excuse me, we have the vertex, which is on the x-axis, so that is an x-intercept. But we have no y-intercepts because it's not touching the y-axis at any point. If we zoom out, we'll see that no matter how far we zoom out, it's not going to touch the y. Our domain and range here, we can say our domain, the smallest x value is 2, and it's going to go all the way to positive infinity. That range value, this one's going to look a little different because of the reflection. If we go from least to greatest on the y-axis, it's going down. So the least y value is negative infinity. But then when it gets to 0 here, there's no more y values above that. So 0 is the highest or the greatest y value. Great job, folks.